Okay, I'm Rosemary Killen, but I'm reporting on some work that was mostly done by Jae Kyung Park, who was a winter student that came from South Korea, and also work that was previously done by Dave Williams, who is working for the Planetary Data System and is archiving the LACE data. This is I'm going to start with my summary because I want you to know actually what we did. In the process of getting the LACE data ready for archiving, we discovered some interesting things, and in particular, the neon and other elements, we saw a sudden increase. And this was on the night side. It was not associated with dawn, and so we know that neon 20 comes from the solar wind, and so we thought, well, this is interesting, and it's also there have been previous measurements of neon, and so we wanted to compare what was happening here. So Apollo 17 left ALSEP package, as many of you know, and associated with this, there was a neutron mass spectrometer and a heat flow measurement. And so in order to determine exactly when dawn and dusk were, we used the heat flow measurement because the timing, it was a little bit ambiguous to begin with because they started their time from the first day, but it wasn't actually the first day, it was the day before the instrument was turned on. So we had to first untangle the actual time, and in order to do that, we decided the best way to do it was to plot the heat flow along with the mass, and that's why. And so we did see this interesting increase in the neon, but in addition, at the same time, we saw increase in other elements, but they didn't all increase with the same ratio. Now, we know what the ratio of neon 20 and 22 should be, and we determined that the neon 22 is actually not, I mean, the mass 22 is actually, this is mass over charge, and so what we're looking at is an artifact here. It's CO2 double plus. That's an artifact coming from the instrument. Question is whether the water is real or an artifact. And we've had a lot of discussions lately with Dick Hodges, who thinks that the water and, of course, the CO2 are all instrumental. But that's another story that I don't really want to get into. As I said, the CO2, the mass 22 is actually mass overcharge, and it's CO2 double plus. But so we know that if there's a CME condition, the heavy elements, not only the proton abundance, the proton flux is increased, but the ratio of heavy elements in the solar wind is increased as well. And so from measurements of many measurements that are studying the solar wind, we know approximately what the increase in neon 20 in the solar wind would have been for a CME condition. And so this is just showing that this is a time sequence going from the bottom to the top. And all of this happened on May 7th, 1973, over a period of about 2 hours. So here's our mass 20. We saw a big increase there. The mass 22, this is the artifact. It's a lot noisier than the 20, which we believe is real. So here's our solar wind data. Fortunately, even back in 73, we had measurements of the solar wind from IMP6. So we know that before the time where we saw this increase, oops, let me go back. Here's our proton, increased from about 10 per cc to about 40 here. There's our measurement, it's approximately here. Now after this, the solar wind speed increased, but the flux actually was greatest about during the 10 hours before our measurement of the increase in neon. So the question is, what's going on here? So these are a comparison with other observations. And so these are the different lunations, the second, third, fourth, and the fifth before the sudden increase were all consistent with the neon densities observed and published by Clark et al. The fifth, we saw this sudden increase of a factor of about 10, and that was actually consistent with what was published by Ben et al. From Laddie. So what we did, we tried to model the increase based on what we have measurements of the solar wind. Instead of getting an increase of a factor of 10, as you can see here, this is the model, and it was done by O.J. Tucker. We have a 30% increase instead of a factor of 10. Okay, so we used a lifetime for neon of 4.5 days, consistent with the fact that all of these measurements were on the night side. And so the other curious thing is some of the lunations, the surface number densities increased over the night side. Sometimes they didn't. This is our increase here. It's before the temperature rise, so it's not associated with increase in temperature. These are the models from OJ, and you can see in his model the neon density on the surface. These are surface number densities of neon should increase over the nighttime and decrease during the day because it's evaporating during the day. We just don't see a huge increase. This is the solar wind data up here. You can see it was pretty noisy, which is fairly normal. Okay, so our attempt to reproduce the enhanced value was unsuccessful. One interesting thing, the photoionization lifetime of neon is 3 months at this particular time. It's associated with the sun. But that's obviously not the loss process for neon. It can't be photoionization. Curious thing is that our measurement is consistent with the Ben et al. Observation, which he claimed was during a CME. The modeling based on a 4.5 day lifetime does not reproduce the enhancement. And we conclude that neon loss is not due to photoionization. We think neon should be in dynamic equilibrium with the solar wind. As of now, we don't have a good model for it. So we've submitted a paper, and I want to give a lot of credit to Sang-Joon Kim and Jake Young Park, who were the collaborators from South Korea. Did a really good job. So thank you.
We have time for questions.
It's a nice talk. I was wondering if you see a similar enhancement in argon or other rare gases. And one of the reasons why I asked that is mass 20 could be argon double plus. And it may track argon.
Yeah, we do see an enhancement in argon. I can show you that. He plotted a lot of argon measurements, and it was enhanced, absolutely.
Any other questions? think everybody is still asleep.
Thank you.
Okay, we'll move on to the next speaker.